TASBot is not AI. But if he's not AI, how does he play games the way he does? How does he flawlessly beat Tetris or somehow put Twitch chat inside of a game? Although TASBot is able to play games perfectly, he couldn't do any of that without a lot of help from humans. What kind of help? A couple quick updates. In 2015, I was diagnosed with a GI health issue that went from mildly annoying to significantly more severe over the last year, despite multiple treatment attempts through local hospital systems. It definitely impacted my mental health, and I apologize for oversharing elements of that before I felt I had to step away from the internet for a while. I've long been a proponent of mental health care, as evidenced by the support I've given NAMI over the last several years. And it was humbling having to seek some of that help myself. I'm very thankful to have a wonderfully supportive community around me, and I'm thankful that I have some amount of hope. I have an out-of-state appointment at a different hospital system coming up, and I have found some relief through symptoms management. But it's been hard, and I hate to be the begging kind of guy, but it's been really difficult covering all of those out-of-pocket medical expenses the last year. If you'd like to help, I have a donation link on screen and in the description, and Patreon support is always welcome. There is an element of this that I want to talk about. Over the last decade, there have been so many charities that the TASBot community has been able to help. And to keep that momentum going forward, the TASBot leadership is creating a TASBot Labs 501c3 nonprofit to help that continuity and ensure that we can keep TASBot playing video games for charity long into the future. If you'd like to get involved in any aspects of that process, come on over to discord.gg/TASBot and speak up. And speaking of TASBot, let's get back to him now. Okay, so TASBot's a robot and he can play video games perfectly, but how exactly is he doing that? To answer that question, we have to go back, way back, multiple centuries in fact. People started inventing new ways of taking existing music boxes and creating oversized drums with large pegs that could play music on much larger devices, even organs. Some organs used air forced through holes or perforations in paper or cardboard or even metal plates in order to play back a pre-recorded song. Regardless of the mechanism, the end result was a prearranged sequence of notes that could be deterministically played back, with the art form gaining widespread adoption by the 1920s. An entire industry of piano roll manufacturers with more or less agreed upon standardized piano roll formats for at-home player pianos existed. Some piano rolls were created by having a musician or a famous pianist sit at a reproducing piano, a type of piano that, as the musician or pianist played, would create perforations in the paper and record an entire attempt of a song in one sitting. Eventually, after a few attempts, the pianist's result would be satisfactory, and the piano roll would be copied and sold to customers to play on their own player pianos at home. This is something like a human playing through a video game speedrun, doing an RTA speedrunning attempt, and taking a single segment best attempt and posting it to a leaderboard online. Now, the challenge with this is any imperfections or mistakes that the pianist made were also faithfully reproduced. One of the ways that they could get around this was by taking a prearranged composition of a song that had an existing sheet music interpretation of it and manually poking holes in the cardboard or the perforations in paper. Now, this was a little bit harder because as you reduce the diameter of a paper roll and its size changes, the speed it plays back at can change as well. So they had to be somewhat careful, but it was possible to manually reproduce a song this way. Now, somewhere along the way, someone realized that a player piano, for instance, a typical piano, has 88 keys, but a human only has 10 fingers. So someone at some point added a little bit extra punch to the composition by adding a few extra notes beyond what a human could normally play. Eventually, several decades and centuries even in the future, we now call those types of compositions black MIDI compositions, where you can play many notes beyond what a human could ordinarily play. sometimes all of the notes, just to be absurd. Now, you might say that a black MIDI composition is the equivalent of a tool-assisted speedrun, what we have TASBot do. To kind of contextualize that a little bit, when we're playing in an emulator, it's possible for someone to recreate a single segment speedrun. A well-practiced speedrunner can sit down in front of an emulator and start recording their play session. And from the beginning of the game to the end, play through as perfectly as they can, recording every single button press from the beginning to the end, save the result, and then we can play it back later, usually on an emulator, but with tool-assisted speedrun replay devices that TASBot holds, we can also take that series of button presses on a sufficiently accurate emulator, interpret them in a format to turn them into appropriate controller button presses, and play them back on a real console. Now, we don't have to do just a single segment of a speedrun with human effort. With an emulator, we can pause the action anytime we like. We can create save states or snapshots in time and load those, or do a what we tend to call a re-record, go back in time and try again from that same point. When we make a save state, a snapshot in time of the state of memory, of CPU registers, and everything else that's going on in the system, we're able to perfectly reproduce that state over and over and over again as many times as we like. So you might start playing a game like Super Mario Brothers and create a save state before approaching a Goomba. Maybe your first attempt in the emulator, you jump over the Goomba's head while running. And maybe that's relatively fast, but perhaps you want to try a few other tricks, see if you can get through that segment faster. So maybe you take a snapshot, a save state, load back to that point prior to approaching the Goomba, and instead of jumping over the Goomba, maybe you jump off the Goomba's head and try again, and maybe it saves a little bit of time, maybe it doesn't. Maybe after doing this many iterations and exploring all of the possible options, you discover that the fastest possible way to get through that section is to jump off of the Goomba, but deliberately get Mario's head embedded in a coin block, and then press in the opposite direction Mario's traveling in to force the game to push Mario forward out of the coin block a little bit faster than if you had done nothing at all. This is something that would be very difficult to execute with human effort alone, but with the ability to go back and try as many times as you like, in addition to other tool-assisted speedrun techniques and tools such as frame advance, basically playing like slow motion, but one frame in advance at a time, advancing one individual draw of the screen, and then the next draw, and holding exactly the keys you want each frame. Or memory searches, so maybe you can identify changes that might be evident at the moment that that collision detection triggers and starts pushing Mario out of the coin block. All kinds of tools that might aid a human in getting a little bit more speed out of the game. All of these things combined mean that you're using human effort with tools to assist creating a speedrun. Now, we oftentimes take this to the extreme, especially for types of content that are shown under the TASBot banner at charity events, where sometimes we'll take advantage of glitches that allow us to take complete control of a game. But there's one element of this that is kind of interesting. It's exactly the same way as playing back a piece of music on a player piano. You see, with a player piano, you're taking a piano roll, for instance, that's a pre-recorded sequence of notes from the beginning of a song to the end, and you're playing those back on a player piano all at once. It might have taken the original composer who put together that piece of music many months or even years to decide on the exact sequence of notes. But to play it back is just a simple matter of taking that recording on that piano roll and playing it back from the beginning to the end, all in real time. We're doing exactly the same thing with TASBot. We're taking a tool-assisted speedrun, made in an emulator, laboriously with a lot of human effort over time, and playing it back all at once, one button press at a time after another. In the context of playing this back on a real console, We have a replay device that pretends to be a controller, usually held by TASBot, who's just acting as our mascot. And we turn the console on. The console asks the controller for a set of button presses for the first frame of input. And the next frame that comes up, the console asks for the next set of controller input. We just keep feeding the console that next bit of input from the beginning of the game to the end. Just like a player piano is playing back one note after another from the beginning of the song to the end, we're playing back one series of button presses after another from the beginning of the game to the end. Now, you might have noticed that all of this was really manual, and that's what I wanted to talk about. When I go to take TASBot to different charity events and I say TASBot plays video games perfectly for charity, and people see various different crazy things happening, one of the things that I find interesting is a lot of folks assume that all of this is being done with artificial intelligence. And that's not the case at all. In fact, very few things that we've ever done that related to the TASBot banner even touched any kind of machine learning or artificial intelligence directly at all. Now, we do use some types of bots in the creation process of making a tool-assisted speedrun. For instance, when we're making a task, we might use a script that automates the process of trying to manipulate luck. Maybe we're trying to get an enemy to drop a particular thing, but it's effectively just Python or Lua scripting or something similar that's just what we might describe as business logic. It's not artificial intelligence, although it is a bot in the sense that you're automating the process of looking for a specific outcome. But it's definitely not the same thing as actual AI playing a video game. For examples of that, you can turn to projects like Mar.io or various different Flappy Bird experiments. Games that are automatically playing themselves. Pokemon, for instance, is a popular thing that's happening right now where different artificial intelligence companies are pitting the various different models against the game Pokemon, especially the first-gen Pokemon games. And it's funny watching exactly how bad they are at it. The reality is that artificial intelligence in the context of playing through a video game might be able to successfully play the game, but it isn't necessarily going to be able to figure out the most optimal way to do it right off the bat, or even after spending a lot of resources on the problem. Even if a simple game, such as the Flappy Bird example earlier, found an optimal route from a time perspective, there's no guarantee it's necessarily going to do that in the most entertaining way possible. For instance, on an autoscroller level, you might have extra time where the level is going to take the same amount of time to complete no matter what. It's just plodding along one little bit at a time, like a rail shooter, for instance. You can't do anything to make it go faster. A human might choose to make artistic choices to use that time to do something unexpected or funny, something unusual or silly, something death-defying or extraordinarily lucky, something that is doing something entertaining without wasting time. An artificial intelligence program might be able to approximate that, but isn't necessarily going to be able to come up with something new or unique. And that actually brings me to the main point. Artificial intelligence is trained on a given data set, whereas a human can source from multiple art styles, but come up with their own unique interpretation and their own ideas of what they want to see. Artificial intelligence, especially in the context of where we're at right now, isn't going to be able to produce something as entertaining in the context of a tool-assisted speedrun as we know it today. Now, there are possible ways that this might change in the future, but there are some social cues that can't be expressed in data sets, aspects of nostalgia or perspectives of what we might find entertaining or interesting. Things that might be appropriate for a specific charity event, for instance. The kind of content that simply cannot be created any other way other than using human ingenuity. That's not to say that we haven't done some things that have bordered on aspects of AI in the past. For instance, at one point in time, we used Alt F4's SmashBot to play through Super Smash Bros. Melee perfectly on a real console. Now, SmashBot, made by Alt F4, was originally designed to run in the Dolphin emulator, And it would work by having Dolphin tell SmashBot where the opponent was standing, like the XY coordinates on the screen. Nothing more than that, nothing more than the layout of the screen and items and things like that. What we did do as part of the TASBot community combining with SmashBot was added in doing that on a real console via various mechanisms involving an arbitrary code execution exploit on Super Smash Bros. Melee, using the memory port to read out those opponent XY coordinate values and item values, and then having SmashBot analyze what was going on and then send the button presses back to the console via TASBot acting as the controller. Having somebody else on a real controller and playing with their own real human skill opposing the SmashBot plus TASBot AI was a lot of fun, mostly for bystanders. People playing generally got pummeled pretty badly, unless it got really cheesy and they found ways to juke the AI and find various different loopholes in its logic. We've also done some other things that were adjacent to AI. Coder Wilson's work with Final Fantasy was fascinating because he used largely machine learning and virtual intelligence. It did allow us to demonstrate a playback, but it's not the same speed as playing back a real tool-assisted speedrun. Everything else we've ever done with TASBot has pretty much had nothing to do with artificial intelligence. And I don't see us doing any AI in particular anytime soon, largely because we just can't get good enough results at this point. Even if we did have something that was interesting, we would absolutely disclose that. Disclosure and attribution is really important to us. In particular, it's really important to me, especially, to make sure that the tool-assisted speedrun author gets attribution for the work they put in the same way that I would want a composer to get attribution. We don't just not mention that a piece is from Bach. That's pretty important. With AI, it starts to muddy who that attribution should go to, because oftentimes we don't know what the data set that AI was trained on even came from. So for a wide variety of reasons, I don't really see us embracing artificial intelligence. It's a whole lot more fun to see what human effort can produce, making transformative works of art.